Okay, so today we will move to chapter 8 about case study. Uh, so generally speaking, regarding data analysis, there are three stages. Okay, for the first stage, what it does, it's load the raw data into a data frame. We're quite familiar with this. Okay. So you have generally speaking, it's a CSV file. Okay, so in Pandas, you can directly call the read CSV function. So this is to load the data and into a data frame. So all of our work is done on the data frame. Okay, then we examine the data frame to understand the data set. So a couple of functions that we learned in Pandas regarding data frame examination include like a header, tail. So if you didn't specify, by default, it will give you the top five or the last five entries of your data set. And info is quite useful because it will review all of the column information, okay? And describe give us some general statistic information about the data set. And also include pre-processing and clean the data. Data cleaning, data pre-processing, if you recall, including like handle missing values, handle duplicate values, and remove unnecessary columns, and also converting data types and some other tasks in cleaning and pre-processing. And in chapter 3 and chapter 4, we learned pandas and some related operations in pandas. In chapter 6, we also learned data cleaning and pre-processing. Okay, so that's regarding the first step. And for the second stage, what it does is to do exploratory data analysis. For exploratory data analysis, it involves identifying trends, patterns, or anomalies in the distribution and the relationships of data points. Okay. Yeah, so to do the data exploratory analysis, normally it involves data wrangling. If you recall, we learned in chapter 6. So this is about to reshape data, okay? Like you add new columns and make the data frame from wide to long, or make the data frame from long to wide. And also you can combine multiple data frames together. Okay, so data wrangling and data aggregation, we also discussed, if you recall. One of the major function to do it is group by, okay, and some other functions to aggregate data and then to do some task like summation, like find the average, find the minimum, find the maximum, do count. Yeah, and some customized operation, okay. And to find the trend, pattern, or anomaly in the distribution, as well as the distribution relationship. In chapter 5, we learned the data visualization. Okay, so how to come up with correlation heat map, the bar plot, scatter plot, line plot, box plot, okay, etc. Okay, so this is the second stage for data analysis. And the third stage is data modeling, okay. Data modeling, we discussed in chapter 7. And we discuss two approaches. And we just gave, in chapter 7, we just gave very, very basic introduction, okay? Because data modeling itself covers a lot of different areas and fields knowledge. And what we discuss both statistical models and machine learning models, okay? And both approach from different perspective, okay? So data modeling, the major purpose is quantify relationships among the variables, okay? So in statistical model, we call like independent variable and dependent variable. So independent variable is X, dependent variable is Y, okay? In machine learning, normally we call them features. So for X, we call them features. And for the dependent variable Y, we call them targets or outputs, okay? So try to find, quantify the relationship among the variables, identify correlations, and then assess model performance using different performance metrics, if you recall, okay? And we discussed three basic models. The first is linear regression. And linear regression is majorly for continuous value prediction, okay? Finds a relationship for continuous value. The second we discuss about classification, and there are a number of algorithms to do classification, and we discuss logistic regression, and logistic regression is one of the basic ones, okay, and also it's quite efficient, okay. And the neural network can also do logistic regression. Neural network can also do data classification. So, and both linear regression, both regression and classification, both of these two belong in machine learning. They belong to supervised learning. So supervised learning is the target. So Y, dependent variable Y, is known. Okay. And the third type we discussed is to group data. So that's unsupervised learning. So we don't need to have Y, okay? We just need to have X. And then you try to find similarities between the data points and then group them together. And one of the approach is clustering. And in clustering, there are also multiple approaches. And we discussed one of the basic is k-means clustering, okay, to separate data into different groups. And in this chapter, we are going to go over two case studies, okay. So let's move to the coding part. I'm going to go back to share screen. I think it should be still recording. Okay, so let's take a look the first case study. Okay, so the first one is about company income analysis. And in summer, when I wrote the book, I retrieved this data set from this link. But this morning when I checked, this link doesn't have the data set anymore, okay? After we finish this case study, we may see why this data set is not available anymore, okay? But I downloaded the data set and I will upload it to the GitHub, okay? So the first is to load the data. Okay, that's the first stage. So loading, examining, and cleaning data. Okay, so you have the file, CSV file, and then you just read the CSV, okay. Generally speaking, we first do a header, okay. So we get a glimpse of the data set, have some basic idea, okay. So if we take a look at this data set, it's about some financial data and let's see, how do I, there are, yeah. So there are a lot of columns we can see. And if you take a look, you will find even with the top 5 entries for the last 5 columns, looks like there are a lot of null values. Okay. So the observation from the first 5 rows, we kind of can see, yeah, there are quite a number of missing data, okay, in those columns. Okay, so it said like operating expense, interest income, interest expense, preferred dividend, net income. So we need to do some further validation to see if we want to drop those columns, or it's just a coincidence, just at the top have some null values. Okay, so we need to do some further examination. And if you recall, this info function for the data frame, it reviews a lot of column information and the null value. Okay, so generally speaking, we also going to call this to do some data examination. And if we call, we can find the total. So this data set itself is quite large. Okay, it has over 69,000 entries. Okay, and the total columns, there are 43 columns. So it's a large data set. Okay, and then it lists of the column name and the null count, okay, as well as the data type. So we do need to examine those information. And from a quick review of the data, you will see like some of the data entries, the number quite low, is it? Because total supposed to have 69,000, but like you see for this column, there are only like 27,000 something, okay? And also there are number like 50,000 something. And you see over here, you also have only 37 something, that, and 36,000 something, 29. Okay, so 26. So for those column, you can see looks like there are a lot of missing values. And especially for the last 4 column, if you take a look, the number are really no for non-null counts. Okay. So from the data info giver, the column information report, we kind of see like over here, it's summarized. Column 39 to 42 have large number of null values. Because of this, then when we do analysis, if we still keep them, normally they will not do good. So they should be dropped. Okay. And the column 38 is, and has over 10,000 null values. And 10,000 is not a small number in this case, more than 10% of the data set total entries. Okay, so this should also be dropped based on our decision. Okay, so over here it's also said there's some other column, like column 6 and 9, also has over 10,000 null values. So they should also be dropped. Okay. So after examining and have this decision, we can call the drop NA, okay, to drop the column with null values over 10%. Okay, so we can set the threshold when you do the drop NA, okay. And you specify, okay, this X is 1, that means it's a column. So after we drop those, and we can do check again, examine again. So after this, you can see the total columns dropped from 43 to 28. Okay, so quite a number of columns got dropped. But if we take a look of the remaining columns, so they are all over 60,000 entries without the null values. Okay. And then we also want to get some statistic information, general status. So you can call the describe, okay, give you the total counts, some minimum standard deviation, minimum, maximum, different quantile, the values, okay. And generally speaking, for data cleaning, you also want to check if there are a lot of duplicate values. So we also examine duplicate entries, and we can see there is no duplicates. Okay. So regarding this duplicator, then we don't need to worry. Okay. And also, if you take another close look about the column name, you will find it's kind of not that standardized. So we want to, when we have our data frame, we want the name have more standardized and have some real meaning so that it's easy for us to analyze. Okay, so you can call the rename and to give column a new name, okay, using a dictionary. So what here we do is using dictionary. So specify the old column name and replace with the new column name like this. This is the old column name, and then you just replace it with like revenue growth. Okay. Yeah. So this, and also we make all of this happen on the original data frame. So in place is true. Okay, after we do this, and we can get a glimpse of our data set again. Okay, so you can check like the column name and some other information. Okay. Okay, what next? Because when you take a close look of the data, you will see the ticker is this is the ticker. So it looks like the ticker occurs multiple times. Is it not just a, but if you take it, it's because of on different date, the ticker will occur multiple times. So we do want to know, is it how many the ticker occurrence that we want to have for each ticker, how many times it occurs. So to do this, you can do the group by the ticker, is it, and then do count. So this is regarding data aggregation, okay? So you group by ticker and then you do count. And then we can see, okay, for each ticker, how many times it occurs. It looks like a majority occurs 20 times because this whole data set is quarterly report from 2019 to 2024. So that makes sense. Okay, so 5 years, and each year you have 4 quarters, so that's why it's 20. But then you will see some of the ticker, they have less than, so they have some missing quarter, okay? So we also needed to determine if we want to keep those or not, okay? And it says each ticker has 20 quarters, okay? But some shows that don't have 20 quarters. So we also want to know if there are too many of such cases, is it? Yeah. And so because of this, we also want to filter the ticker, which has less than 20 counts. Okay, because if they don't have complete quarterly report, when we do some analysis, it's also going to cause some impacts. So we can do this filtering. Okay. So then we filter the original data frame, so we store it in the filtered data frame, and then we can also have some statistic report. Okay, and at the same time, we all for the filtered data frame, and then we can do the group by ticker again, okay, and do some examination for its count. So after we filter out, okay, you can see the total count dropped, okay. So not a lot, okay, because the total originally is 59,000, okay. So didn't drop a lot. And now for the group by ticker, you can see it's less than 20 are dropped. Okay, so that's the first part, the stage one of data analysis. So mainly you load the data and then you do data examination, do some data pre-processing and cleaning. Okay. For the second part is data exploratory. Okay. Exploratory, it involves wrangling, aggregation, and visualization. Okay. So let's take a look. And also for the column, there are some financial definitions, okay, like what is revenue growth, gross profit, shares outstanding, earnings per share, gross margin, profit margin. So those are more economic terms. And if you're interested, you can do more investigation. Okay. So if you are major in economics, that makes more sense. Okay. And if you recall, the data set has a column called date. Okay. And a lot of times for the date column, it's not daytime type. It's just string type. When it's string type, it's not for analysis. It's not helpful. Okay, so normally for date related column, we want to convert them to daytime. So you can call the to daytime to convert it. Okay, so we can convert. And also in this case, because it involves year and quarter, okay, so we also want to extract year and quarter out, okay, so that later on we can do some annual analysis or quarter analysis, okay. So that's why here we extract the year and quarter from the original column and add them as two new columns. Okay. And also for the original data set, the quarter, it's quarterly. The quarterly, it's not standardized. Okay. The date. So that's not going to be convenient for analysis. So we want to create a standardized data format for the end of each quarter. Okay. So this function defines how do we standardize the end of each quarter. Okay, so that later on it will be convenient for us to do analysis. Okay, so then we create this standardized new column. Okay, so so we apply the above function to convert the the end of quarter date to the standardized date. And after that, we also do the conversion, okay? And after that, we can take a look of some of the value. If you take a look, you will see, yeah. So now it's standardized, is it, for each quarter, okay? Previously, it's not standardized. Okay, what to the next part? We try to do some sorting. Okay, so we sort by the sector column and the ticker column. So first sort by sector and then by ticker. So for each sector, then it's sorting by the ticker. Okay, so that's what it arranges. Yeah, you can see it's arranged by first by sector and then by the ticker. Okay, and for this whole data set, we may also interested in the unique, how many unique sectors. So what are those sectors we want to know? Is it we may also want to know a unique ticker, is it because there are a lot of duplicate tickers information because of it's a quarterly report. Okay, so we want to know those information so you can call this a unique function. Okay, so it will give us the unique sector and the unique ticker. Okay, we can see there are 11 sectors and 2,905 unique tickers. And then because of this, and we can group the ticker by the sector. So here we group by, we use sector as a group key, okay? And we group ticker, okay? And with the unique ticker, okay? And then we can set the two column name as sector and unique ticker. Yeah, so you see, we get this sector and the number of tickers under each sector. And with this information, then we can do plotting, okay, for each sector, how many tickers they have, so that we can have some ideas. We do, and for this basically kind of frequency for different categories. So normally bar chart is a good choice. So we choose bar and we do horizontal bar, okay. So it's give us, okay, regarding this data set, we have some idea, okay, the largest number of tickers come from financial services, is it? And the fewest number is from utility. So we kind of have some idea about the number of tickers distribution in different sectors. Okay, and if you recall, we have some null values for the columns, is it? And because we are going to do some analysis, so you do need to find a strategy to fill the null values. So important ones. So here we pick some, okay, columns to fill like revenue share outstanding, EPS, gross margin, profit margin, okay. And we are just going to, because they are missing, so we are just going to fill with, we pick the 0, okay, to fill it. And this is regarding the sorted data frame. We also going to convert the date to daytime, okay? And then we extract the year, okay? And then we are also going to group by the sector and the year. and we are going to find of the different columns, okay, and their mean value regarding the sector and the year distribution so that we can have some idea. So we generate the result is going to be a data frame, okay? So with this data frame, then we are going to, because it's for different column, okay? So like a revenue, like a gross margin, like EPS, like those information, etc. So for each column, so we have multiple columns. So that's why here we do a loop with the column. And for each column, then you have different sector. Okay, so that's why here, then for each sector, then we want to find their respective value, the distribution for different year. Okay, so then we can do this plotting. Okay, so then we want to know how the mean of the overall sector distributed over the years. Okay, and based on this, the plot we get is listed here. So this is the first one. The first one is about revenue growth. And for different sectors, for each sector, we have different color, okay? And so this is about revenue growth. And from this revenue growth, this color, if we take a look, it's from healthcare. And this kind of very abnormal, okay, because it's so large, the growth for certain years, like 2021 and 2023, okay. It's growth over thousands. So this has some doubts on it, is it? So that's we kind of doubt this. It's kind of off chart too much, is it? Because it's for the overall, the whole sector, okay, like for the healthcare, okay. And then this is the shares outstanding by sector, okay? And also, if you take a closer look, like a communication service, also like off, compare with others, it's a large gap here, okay? So we also have, this may also raise some questions, okay? And then for this EPS for the sector, then for some reason, 2020, okay, and the color is purple, so it's energy. For some reason, the energy, the purple, for 2020, it drops also over like 1,500, also over 1,000. And it's also off chart a lot for this value, okay? And then gross margin. For the gross margin, if we take a look for the 2021, okay, this is utility. Utility also dropped a lot, okay. Yeah, so it's also kind of kind looks like abnormal, okay. And also, especially like you see for profit margin sector by year, and this is industrials, okay. So it's also dropped so much, also over 8,000. Okay, and also the pink one is healthcare. Also, profit margin, it's far below even 2000. Is it negative? It's negative 2000. So this is also doesn't look normal, especially for this health care. This is profit margin. And if you recall, and the revenue grows year by year, then it's also off the chart. So this health care, this this graph and the first graph also, these two graphs regarding the same second sector also doesn't review like a consistent pattern. So this is also very abnormal, is it? And same thing for this data. So this has the same issue as the profit margin. So based on the revelation of the above plotting, yeah, so we see like the healthcare sector in the first plot presents abnormal high, okay. And then for the EPB, okay, the energy sector also present abnormal low value. And the gross margin also has both high and low, okay? And also for the profit margin, also present abnormal low value for industry and healthcare, okay? And same thing for the TDA margin also prevents abnormal low for industry and healthcare. So all of this just gave us impression that the data source may not be reliable. So our conclusion from the above observation, we say that data source is not reliable. So it's not worth to do some further investigation like modeling, is it? And after I analyze the data, I find it's not reliable. So, so I think maybe that's the reason this data set, the owner may take it off from Kaggle. Okay, that's maybe the reason. Okay. Okay, then let's take a look the second case study. For the second case study, it's about sleep health and lifestyle analysis. Okay, so the original data set, it has 400 rows and 13 columns. Okay, it also covers a number of features. Okay, columns. And it has information about gender, age, occupation, sleep duration, quality of sleep, physical activity, stress, BMI, blood pressure, heart rate, daily steps, and are there any sleep disorders, So the key feature of the dataset, it provides comprehensive sleep metrics, lifestyle factor, cardiovascular health, sleep disorder analysis. And this dataset is still available. Okay, so it doesn't have any issue. Okay, so same thing. The first stage, we load, examine, and clean data. Okay, I also download this to my local drive, and we can examine the data. Okay, so yeah, it has a number of columns. Okay, and here gave us the first 10 row of data. It says there are it's just note, you can just notice there are a lot of duplicate values. Okay, and here give some examples. So because of duplication, so we need to drop the duplicate entries. Okay, and also it said column sleep order has quite a number of null values. Okay. And if you do a more careful examination, you will find that basically it's not missing data. It's just represent individual that does not have sleep disorder. So they didn't record. Okay. So a lot of time you also need to examine the data. Okay, it's not just it's no, then you just consider no. No, sometimes maybe it's represent normal. Okay, the situation is normal. Then we don't need to do some import. Okay, so the info is check each individual columns. So total, we have 374 entries. And the total column for this data set is 13 columns, okay? And if you examine each column, you will find, yeah, majority of them, doesn't have any missing value. It's just the last one. But last one, we already explained. It's not missing. It's just represent individual, doesn't exhibit any specific sleep disorder. Okay, and we find there are a lot of duplicate values. Okay, so we want to know how many duplicate entries we have. Okay, so you can find the duplicate, and totally we find there are 242, quite a lot. 2/3 of the data, okay, are duplicated. And because of this, we need to do the drop duplicate. Okay, after that, then let's take a look at the cleaned data. So clean data, now you see of this, okay. So we drop 2/3 of the data, okay. And because of the last column, now we cannot just leave it there. We need to fill it for the analysis. So we are going to fill it because its type is not numeric, it's a string. So basically it's normal, so we just fill it with no disorder, okay? After that, we can do the info check again. Now you will see, yeah, there is no missing data, okay? So all of the data are filled. And then if you take another close look of those data, yeah, you will find like for the BMI, okay, for the occupation and the gender normally over here, yeah. Sometimes you may also want to convert to numeric for further analysis, okay? But BMI, maybe we are going to use it, do some a numeric analysis. So but BMI, you can see it's categorical data, basically. It's a string, so we want to convert it, okay? So BMI is, and there are some other columns, okay? Okay. Okay, like over here, the gender, occupation, we already see. Is it BMI? Blood pressure, we are also going to see. And the sleep disorder, they are all non-numeric data type. Okay. And if we take a look at this column, you can also see, is it like gender, occupation, okay, and BMI category and blood pressure and the sleep disorder, okay, they are not numeric data type. And further observation, we already see that BMI it says has two numeric, not the BM, that's should be the blood pressure, okay. It has two numeric separated. So we are going to sleep the two numbers. And BMI and sleep disorder, they are categorical data type. Okay. For categorical data type, when we do modeling, we need to convert them to numeric data. Okay. So we needed to do some further data conversion. Okay. Okay, and we need also to find out what unique BMI category, what unique sleep disorder category values are. Okay. And after that, then we can find, okay, BMI, it has four different category. And the sleep disorder has three different categories. But if we take another look, you will see overweight, obese, normal and normal weight. Normal and normal weight should be the same category. As overweight, obese may also be the same. So we should combine, we should redefine that. So that's why over here, we are going to replace the normal weight with normal, overweight with obese. Okay. And after that, then we are only going to have two categories for BMI category. Okay. And blood pressure, because it uses the slash to represent the systolic and the diastolic. But we want to have those two as two separate numeric values. Okay, so that because with numeric value, then we can do some modeling. Okay, so that's why we split, we call the split function from the string, Python string class, okay? And then we extract the systolic and diastolic, and we add this to new column, okay? And also convert them to integer type. And because we have systolic and diastolic, so we can drop the blood pressure column, okay? And for BMI and the sleep disorder, we want to convert them to numeric. And over here, because they are quite simple, so you can just directly call the map function and plug in the dictionary. Okay. Okay. Normal with 0, obese with 1. Okay. No disorder, sleep, apnea and insomnia, etc. Yeah, so that we can convert them to numeric values. And after that, the values are converted to numeric values. And after we do all of the above cleaning and conversion, etc., and we can get a glimpse of our data again. Okay, so here it reviews the data, okay, and also give us the statistic information about the data. So that's the first stage. We do the data cleaning and the data pre-processing. So today we just going to stop here for the second case study, okay? And next class, we are going to continue our discussion for the second case study to do the data exploration and data modeling. So that's all for today.